We'll see what we get to. I'm not sure yet. We'll see how much we get to tomorrow, probably. Okay, did we copy down the last bullet point on the slide? That chemists draw a circle around where the electron is 90% of the time? That's what an orbital is. An orbital is where it's not, a physical boundary you can see. It's just that that's where the electron tends to be most of the time. The electron can be outside that orbital. It's just not as likely to be outside the orbital. So did everybody have this one down? You still need to write that down? Okay. This is still 5.2. Finish that one up today. Okay, everybody ready? Okay, the quantum theory is just that you have these orbitals where the electrons are going to be most likely throughout the, it's not exactly like orbits, it's similar to orbits, but the difference is that with an orbital, it's the three-dimensional space that they can be in. Think of it like a balloon. But there's no boundary, you don't have a physical boundary. It's just that most likely it's going to be within this circle, usually. Now, it can be a different shape besides circle, but we'll talk about that in a second. But the first orbital shape is just a circular sphere shape. So principal quantum numbers, we talked about this yesterday or Friday. Niels Bohr talked about this, that you have energy levels, that the energy level goes from 1 to 7. And that number indicates the size and energy of the orbital. So larger number, larger energy. So number 7 is the largest energy. Number 1 is the lowest energy state of an electron. So as we talked about, Niels Bohr discovered that there are 7 energy levels. He numbered them 1 to 7. Within those levels, though, you have other sublevels. So sublevels are S, P, D, and F. Those basically indicate the shape of the orbital. The one that you're seeing on this page is an S. That's a spherical shape. And that's the simplest shape, but it gets more complex.
How are the levels created? Like
How are they created?
Yes. Like how are they do they always exist or do they like?
Oh, I see. They're always available. They're kind of like rooms where, like a room could have people in there or not. So there's always a space for an electron to be, but it's not always there. So kind of like just like rooms in this class, in this building, right? I mean, the rooms are always there, but people may not be in the room.
So do all atoms have 7?
Yeah, every atom has 7 spaces that electrons could be.
Can they have more?
Do they have more? No, they only have 7 energy levels. That's all that any atom would have.
Okay.
And so every atom, the simplest is hydrogen, most complex, they all have 7 energy levels that electrons could be in.
So how many levels would hydrogen use?
Well, hydrogen can use all of them if it's excited enough. So enough energy given to hydrogen will make that electron jump to energy level 7. But generally, for the most part, it's going to stay in level 1.
How hot does hydrogen have to be?
How
to get to
hot?
level 7?
Generally about 10,000 degrees or so,
Yeah.
which is, but it can be lower, but I mean, it just depends on how much you have. Okay. So as I mentioned, S orbital is the simplest shape. So more complex shapes are more energy. So the simplest shape, it has lower energy than a more complex shape. I don't know why it's doing this. I guess. You like it?
Fade on accident?
Yeah, I don't even know. Oh, sorry, Andres. Didn't see you there. Well, he's using his brother's name. Sorry about that. I didn't see you were waiting in there. Let's see. Hmm,
Do you have his volume down?
Do I have his volume down?
Yeah, the output volume or something.
No, why?
Oh.
It's
He was
probably,
just telling me that he was trying to talk one day and nobody could hear him.
he must have been on mute.
Oh.
That's all I can think of. I don't know.
May I use your children?
Oh, well, I guess I'm not gonna worry about it transitioning. I can't really see how it did that, but it's not a huge deal, I guess. So. Okay, so S orbital, lowest energy orbital, we have P, D, and F that we'll get to later, the more complex shapes. And you can see on the left-hand side, you have 1s, 2s, 3s. And so you have higher energy levels where you get a larger orbital. And so 2s is higher energy than 1s, and it's bigger.
And it goes up to 7S?
Not all of them go up to 7. So not every S, P, D, and F are going to go up to 7. We'll talk about which ones do and which ones don't. But they don't all go up to 7. They don't always start at 1 either. So S starts at 1, but the next one we'll talk about, P, starts at 2. So they don't all go from 1 to 7. Okay, so the next one, so these get more complex in their shapes as we go up in energy levels. P is the next energy state after S. And it has 3 parts to it. So you can see that there's the Z, remember the Z-axis before in algebra 2? You know, we know Y and X pretty well, right? But there's also a 3rd dimension Z. And so you can see on here, you have a Z-axis where this is on the Z, then you have an X-axis, then a Y-axis. And so the orbitals are 3 dimensions, and you have 2 lobes in each of those 3 dimensions for a total of 6 lobes. And so the P orbital actually looks like the bottom right corner, the purple one. That's what you would really see as the P orbital with 6 lobes.
Would it be one electron makes one lobe, another electron makes another?
Yeah,
lobe?
when it's full, you're gonna have 6 electrons in there.
Oh, okay.
So each lobe would hold 1 electron. You can think of it that way. So basically you had 3 parts to the P orbital, Px, Py, and Pz. So it's just higher energy. Now, really think of it as you can see in the cloud, you know, where you can, this right here is more of what you would see, where the electrons would be in this area, not so much in the middle part. That's more of what you should envision it as. So again, we get more and more complex as we go up. So next is D. So we had SP, now we're on D. The D orbital has 5 parts to it. And that top picture shows you the 5 parts to the D orbital. They're all put together. And the bottom picture shows you what it looks like when they're all put together. It's hard to see individual parts when they're put together. That's why we separate it out. But basically, it's similar to the P as far as, you know, the individual lobes to it. But it gets more complex. And so you can see there are 4 lobes per dimension. And we also have a torus, is what this is called. It's a donut shape. And so you have this donut shape that surrounds one of the orbitals, and that makes up dz squared. But those all put together to create the bottom picture that you see as 1 d orbital, and that holds a total of 10 electrons. Yeah, it's gonna get really annoying really fast. I don't know why it's doing that. Okay, so your book doesn't show the d orbital or the f because they're complex shapes, but I think it's good to know what they look like. So I'm going to go through what the d and f orbitals look like, but your book does not show those ones. Okay, the last one is the f orbital. So this starts with 4f. You know, so s starts at level 1, p starts at level 2, and then d starts at level 3, and then f starts at level 4. So F is the most complex shape. You have 7 parts, so you can see in this picture that are all put together to make the F orbital. They hold 14 electrons in total within all these lobes. So you can see that they have similar components to what you saw in the D, where you have, these dumbbell looking things, pinwheel looking things, along with a donut shape around some of them. So again, envision all these stacked together. It's hard to see that in one picture, so they usually show them pulled apart from each other. But the F orbital would have these all stacked on top of each other.
I'm confused as
Good.
to what you mean by like they start, like,
I'll explain in a second. That's not as clear at this point. We'll talk about that a little bit later. But basically, we have energy levels 1 through 7, right? And within those, we have subdivisions. Really fast, I'll draw on the board. It's easier to do that. So imagine it like this, like you have a stadium where you have, the stage right here. And then you have different rows, right? And
They have
so
a picture of this in our book.
it does.
Yeah.
Let me see, before I go through trouble drawing this, let me see if it's in your book that you can explain it better. On page 153, it kind of shows that, not kind of. I mean, not really though. Let me go through it. Can you see that? Okay, so think of it like this. We're like in a stadium, you have different sections, right? You have section 1, section 2. In section 1, you might have standing room only. So this might be the area where you don't have any chairs. It's just standing room only. Where you're just in a crowd. And then for this level right here, this might be where you have chairs. And you can sit down. So think of it like this, where 1 is the row, and then the next part would be standing room only or chairs. So what we can say is that in row 1, we just can stand and that's it. In row 2, we have chairs. But what about also in row 2, we have Cowboy Stadium, where you have the party plaza, what do they call that?
Yes.
Is that what's called party plaza, where you just go and it's in a place you just stand and you can see the stadium.
Yeah.
So maybe this part right here is also
The bar?
standing room only. So level 2, level 1 only standing room only. By level 2, you might have part that is standing room only in part that has chairs, right? See with me so far on this? Okay, so what does that mean? Well, row 1 only has standing room only. Row 2 also has chairs. So what we can say is that with row 2, with level 2, we start having chairs, but level 1 does not have chairs. So think of it like that when we talk about when it starts with 4F. Level 4 is when you start having F orbitals. Below that level, you don't see F orbitals. And you can think of it as rows, where like this is a nucleus, and you have orbitals around the nucleus. And then F would be way out here in level 4.
What are the levels? Like, are they just energy?
Basically, energy levels, which indicate basically how close they are to the nucleus. So 1 is the closest energy state, which is close to the nucleus, and then it's basically how far away they are from the nucleus.
Are they like physical?
In a way, I mean, it's yes, and they are. I mean, it's kind of like rungs in a ladder or steps on a staircase. I mean, it's how far away electrons are from the nucleus.
Okay.
Does that clear that up?
Yeah.
Okay.
So in one atom, you can have, in the first energy level, you can have a circular
Right.
orbit, and then same thing with the second and third. And on the 4th orbital, you can have those.
Yeah, there's more than just that, but that's part of what, yes, that's part of what that's saying. Yeah. And I'm going to go through exactly now. We'll talk about this in detail. So to recap what we did and to explain this in better detail, there are 4 orbital shapes that we talked about, S, P, D, and F. And this shows you what they all look like. So the red S, the sphere, P has 3 parts to it. You can see those in yellow. D, the 5 lobes create 10 electrons. And then the 7 lobes for F in green give you 14 electrons. So S has 1 orbital, 2 electrons. P has 3 orbitals, 6 electrons. And this part you should write down. I don't think this was in your notes. So just make sure you do write down how many orbitals each one has and how many electrons it holds. So S holds 2 electrons and it's 1 orbital. P has 3 orbitals and that can hold 6 electrons in total. So each orbital only holds 2 electrons. And then D has 5 orbitals and that can hold 10 electrons. And then F has 7 orbitals, which can hold 14 electrons.
Is it just double the amount of orbitals?
Exactly. Each orbital holds 2 electrons.
Okay.
And you can have all of this in a single atom.
Yes, yeah, every atom has all this. Now, not every space is filled, but every atom has these rooms where electrons can be. So hydrogen can use the F orbitals. An electron can jump from the S orbital to the F when it's excited, and it can go to the F orbitals.
So is it like, it can get to level 7, and then if it gets more excited, it just turns into F?
Then it would just, yeah, it gets up to F, then if it gets even higher energy, it just jumps out. And it becomes, that's plasma at that point. When it just jumps out of the nucleus and just goes into the atmosphere. So it can get so excited, it jumps away from the atom and it emits itself. And that is plasma. You see it glowing, basically fluorescent lights is plasma, the sun is plasma, lighting is plasma, it just jumps away from the nucleus altogether.
Are they both the same as like energy levels?
Orbitals and energy levels are similar, but not the same. So orbitals deals with the shape. Energy levels deal with how far away they are. So let me go through, I'm gonna write this on the board really fast before we go through this. To explain this better. We couldn't turn this off, so.
Wait, were we not gonna?
We will go through this in a second, but I just want to, let me turn the lights on so you can see this really fast. We'll go back to that. Okay, just to help clear this up a little bit, as far as how this looks. Okay, so you start with the nucleus in the middle, right? And then you have the first orbital is 1s. It's just to remember, I mean, this is just, you just have to memorize this, that the first orbital is 1s. And so what does this say? 1 is the energy level, s is the shape. So you have 1s, you have 2s, so s tells you it's spherical, that tells you the shape, and then 2 is the energy level. And so 2 is higher energy for the nucleus than 1 is. You have 3s, which is just a bigger orbital. It's also spherical. So the number basically tells you how big the orbital is. And then the letter tells you the shape. Then we have more. We go up to 7s. We just can't, I don't have space for all of them, but it does go from 1 to 7s.
If it's levels, like will it only have one of the letters? Or will it be like, could you have like S and then like?
Yeah, you definitely can. We'll get to that next. So yes, so you can, well, let's go through this. So how does this build? It builds like this, where you have, let me erase through this for a second. Let's say you have an atom with 2 electrons. So that's helium. That's all it has is 2 electrons. Those electrons will be in the ground state, close to the nucleus. They'll be right here in the 1s orbital. So the first 2 electrons of the atom will be in 1s. And when it has 2 electrons, it's now filled. So let's go on to lithium next. So lithium has 3 electrons. So lithium would have 2 electrons normally in the 1s orbital. And then the extra one can't go in here because 2 electrons fills it. So the next one has to go into the next orbital up, which would be 2s. And so you have the 3rd electron right here. Go on to the next one. Beryllium has 4 electrons. So now what would happen is you'd have another electron in the 2s orbital. Move on to the next atom, to that boron, has 5 electrons. So now you have the 2s orbital filled as well. So what's the next orbital after 2s? We're never going to the extra going to the p orbitals now. So this is where it gets more complicated because it doesn't just go from 2s, 3s, 4s, 5s. What it now does is it jumps to different shapes. And so you have a p orbital with so like this. Now, the next lobe would actually be this way out of the board. It would go in and out of the board. I can't draw it like that, but you'd have a 3rd lobe that would be going this way. So I was kind of drawing the side right here, but this would be coming out of the board. So this is called the 2p orbital. And the electrons will now fill up this orbital right here. And we have 6 lobes to it. So what would happen is you have beryllium with its 5th electron would now go into one of these p orbitals right here. You keep on doing that. So carbon would now have another electron in another orbital right here. Nitrogen would have another electron in here. Oxygen, another electron right here. Fluorine, another electron right here. Neon, another electron right here. And so now at this point, neon now has 6 electrons in the p orbital. And now that's all filled. Let's go on to the next.
Wait, so
Yeah.
s orbitals have 2,
Yes.
p orbitals have 1.
6. Well, I mean, one little lobe holds 1 electron, right? But 2p altogether holds 6 electrons.
No, mine is like,
So 1s holds 2, 1p holds 1.
Well, yeah, I mean, one little lobe, right? But all of it together, the 2p orbital together holds 6 electrons.
Okay.
you're fine.
So why wouldn't it just go to like 3s?
Because it's actually, the 3s is further away.
Okay.
And you can see right here that this is pretty close to nucleus, right? So it's easier for electrons to jump from the 2s to the 2p than to go to the 3s, which is further out away. Okay, you with me so far on this?
No.
What part don't you
Halfway.
understand?
Like everything.
Everything?
Like I just don't understand like what is all this? Like
It's rocket science, y'all. Come
What
on.
is it? I mean, these are spaces for electrons to be, right?
No, it's
Electrons
nano.
live in these little rooms. You can think of it that way. Orbitals are rooms for electrons to be in. And this is the path they take. So an electron that's in this orbital would follow this path. It would stay in this location, right? An electron in the 2s orbital would move in this area. So basically, it's just the way electrons move and where they stay. So the shape
But if
tells
it gets
you
more
just
excited.
where they move.
And you just.
When they get more excited, they just go into higher orbitals. So if this one got excited, for example, then it would move on to the 3s. It would go into a higher energy state.
Oh, yeah, I know that.
Why'd you ask?
No, I was pointing it out that they can.
Oh,
Change
you're
the
showing
feelings.
us how smart you were.
Yeah, I know.
We're running out of colors.
See, I drew this before.
No.
Okay, so this next one right here is 3s. Now, how do you know which one is which? It's just memorization. You just have to memorize that. You start with 1s, you go on to 2s and then 2p. It's just, that's all I do, just memorize that order. There's no logic to it, it's just memorization.
So if you're adding electrons to an atom, are you also changing its like orbital shape?
In a way, I mean, they're always present. These orbitals are always in an atom, but they could be full or empty.
So if you have like 1s and then you like add more electrons, are you always gonna create 2p or are you?
Well, yeah, once 1s has 2 electrons in it, it has to jump to the 2p orbital.
I
Like
thought it was
always?
to 2s.
Okay.
Oh, I'm sorry, 2s, yes, good, yes, 2s. It has to go from 1s to 2s, and then 2s to 2p. So, once 1s is filled, it goes on to 2s. Once 2s is full, it goes on to 2p. Once 2p is full, it goes on to 3s.
Okay.
And then 3s has 3 sublevels.
So 3 itself has sublevels, right? But 3s only has
It's
2
one sublevel.
electrons. 3s just has 2
So
electrons.
the other 2 sublevels are 3p and 3s. Or no,
We'll get to
3d.
that- We'll get to that in a second. Yeah, I wasn't gonna just yet. Okay, so what do we have now? 3s. So we're at, we're now at 11 electrons with sodium. So we have 2 in the 1s, 2 in the 2s. We have 6 in 2p, that gives you 10. And then you have, need one more for 11 for sodium. That one extra goes in the 3s. 3s can hold 2 electrons. So going on to the next one, which is magnesium. Magnesium has 12 electrons. So now we have an electron out here. Now the next one that we go on to aluminum, that one has 13 electrons. So what's next? Well, next is 3p. So 3p would have the same shape as 2p. It's just gonna be bigger.
Is there not a 1?
There's not a 1p. No. P is too complex of a shape for it to be in level 1.
Okay.
It's kind of like I talked about before with the stadium. Like you have a level 1 where it's only saying no chairs in that level. But then level 2 has chairs. It's kind of like that. Okay, so the next one, which is gonna be hard to draw in here in this space, but you'd have the 3p would just be bigger in size. And it would come out past the 3s. So this is 3p. It's got 6 lobes on it. So as you can see, this gets really complex. It's hard to draw this all together. It's hard to see
How
what is
long
what.
did it take scientists to figure this out?
Until
How
pretty
did they
recently.
figure this
They,
out?
it's been.
I mean, it's a pretty recent discovery. In the past,
Man, it's just the answer. Math is the answer to everything.
But like,
I should have guessed that.
they can't
Math equals.
be inside of it.
no, they use equations. All the equations and a lot of experiments with light, especially, led to this discovery. But it's only equations that tell them this has to be true. They can't see it, but all the math tells them this is what it looks like.
That's so weird.
It's just the equation of the
Is it
slope.
just
That's
like-
it.
Are those
That's
like
how you find it. That's how you find it.
like little?
6 lobes, that's right. Yeah, there's 6 parts.
Like that's one-
That's one orbital. That's right. Yeah. So 2p has 6 parts to it. Okay, so we have just memorized this. We have just memorized, let's write down so far we learned about how this builds. What do we learn? That it builds like this. We have 1s to begin with. Then we have 2s. Then we have 2p. Then we have 3s. Then we have 3p. So that's the first orbitals. That's how this builds.
Is it possible to overheat your brain?
Sure.
Really?
Yeah, sure. Definitely.
Like
can.
just by thinking or something?
Yeah, sure. Then you just need to rest. Like your brain just, basically you're tired, right? And when you're tired, you're just working too hard.
That's all.
It's like the job.
Okay, so now what do we do is we don't just write down the order of the orbitals, we also write down how many electrons we have. So how many does 1s hold?
2.
So we're gonna write superscript. So we'd write 2 up here to indicate that we have 2 electrons in the s orbital. Good, so 2s also holds 2 electrons.
6,
6, so we're gonna write 6 for this one.
2,
Good,
6.
good.
Wait.
So p orbitals always hold 6,
14,
and then s always holds 2,
27.
no matter what number is in front. So this is just telling you how big it is, right? And so 2s is bigger than 1s. They're the same shape, they're both s, they're both sphere. What's different is that 2 is bigger than 1. 2p versus 3p. They're the same shape, p is just 6 lobes to it like a pinwheel. The difference is that, that's how I think of it, like S is sphere, P is pinwheel. That's how I remember the two shapes. But it's just that 3 is bigger than 2.
How come you just jump from like 2s, which has 2 electrons, to one that has like 6?
Yeah, it's just, that's just how they are. I mean, it's just, that's the next energy stage.
So if
So-
you only have like 3 electrons, would that be 2s?
If you have 3 electrons? So if you had 3 electrons, then what you would have would just be, yeah, you'd have 1s2 and a 2s1. Like if you were to have, so that would be lithium with 3 electrons. Lithium would be 1s2, 2s1. You'd have 1 electron in the s orbital, the 2s orbital, 2 electrons in the 1s orbital.
Why do you have 5?
5 electrons? Okay, so what would we do? So 2 right here, 2 in here, 4. What's next? 2p.
Okay.
So then you have 2p1.
Do you always starting to the one end?
Yeah, you always start, this is always how you start. You always start at 1s, then 2s, then 2p, then 3s, then 3p. You always start that way.
So if you had 6, you wouldn't, it wouldn't.
That's right, yeah. Yeah, you'd always start with 1s2, 2s2. So for 6, it would be 1s2, 2s2, 2p2.
So if they got the UUSD, the 117, would you be filling up all the
That's right.
P's, like all the way up to
I know.
D15 or whatever?
Well, not P15, but,
Yeah, D something.
oh,
or other.
yeah, you do the D's, yeah, so that's right.
Jeez.
Okay, let's do a complex one.
That was excuse me.
That was a
but-
simple one.
Quick question, if that's the simple one, I'm tired. Why do we have to do complex?
Okay, let's look at one that has, let's say, well, let's do Krypton. 30,
How long is this go hold?
So-
I think I've gotten it. I think.
let's see.
Dude.
Shut up.
Okay,
Shut it.
so Krypton has 36 electrons. So how do we do this? We always start with 1s. So 1s holds 2.
Yeah.
Then we do 2s, 2. What's next?
2P.
2p. How many? 6. What comes after 2p?
3s.
What's after 3s?
Six.
What's after that?
27.
We didn't talk about this.
Oh.
B1. 4s. 4s is next. It's just memorize it. This is just memorization. There's really no way to know that. But 4s2 is next. What comes after that? Actually, now there's a surprise. It's 3D, which doesn't really seem to make sense. But the D is a complex shape. And because it's complex, it's easier to be in level 4s than in 3D. So 3D comes after 4s because 3D is such a complex shape. It's easier to be in 4s than 3D at first. So the 4s fills up first, then the 3D fills up next. So we have 5 orbitals, right? But 5 orbitals hold 10. Because there's 2 electrons in each orbital. So 3D 10, what's after 3D 10? So that's a good guess, right? But actually, we don't have the F just yet. So what comes after that would actually be 4P. And again, this is memorization. If nobody knows, it's just memorizing the order of this. Then what's after 4P? 5S. You might think so, right? That's not yet. Yeah. Next is 5S. So where are we so far? Are we almost there? Actually, you know what? We went too far. We actually would stop right here. This is actually where Krypton would be. This is now at 36 electrons. So that's why you do Krypton. Now, let's go on to, well, you know what? Let's do radon. Radon. Radon has how many electrons? It says 86.
Oh my gosh.
Now, what's nice about this is that it always starts the same way. So this would also be all in radon too. We'd have all of that in radon. So it's always the same pattern. You guys can repeat all of this.
Wait, is that 34 or 36?
Should be 36.
4, 6, 8. Oh, yeah, it is.
Okay. So now we're up to where we were with Krypton. And I mentioned, now we have 5s. I'll just go down here and sign this all together, but we're gonna space it there. So next we have 5s.
Do we have to memorize this?
Yes, but well, in a way, I'll get to what you have to like. But yes, you need to be able to do this on homework. Okay, once you get this, it's not, now the beginning part, it seems strange, but once you get this, it is simple. It's like a new language. Once you know the language, it's easy, but before you know the language, it's confusing.
It's like.
So what do we have? So 5s, and after we have 5s, what comes next is 4D.
Oh my gosh, I got it right. Warren got it right.
4D, and after 4D,
No, this is.
have
Yes.
5P, 6, and then after 5P6, we have 6S, good, 6S2. After 6S2, what do you think you have?
6P.
Almost, we actually now have the F. Finally, we have the F.
5D.
We now have the F orbital.
Gosh,
Four
dang.
and 14.
Wait, A, B. No.
So there's 14 in the F orbital. Then what do we have? We have 5D. 5D10 is next. Then we have
Where's
6P.
And like Z and X. and all the other
6.
numbers.
And that now gives us the electrons we need for radon. That's now 86 electrons. So that seems like a lot. Now, the periodic table though does help you with this. So let me go back to that. Let me go back to the slideshow really fast and go through how we can use the periodic table to help us with this. Turn the lights off really fast. Do you all have a periodic table with you right now that you can write on? Does everybody have their own periodic table? You're gonna need this for your exam, your final exam. Make sure you have your own. You cannot share, so make sure you have your own for the final exam. Make sure also that there's no writing on your periodic table. If there's writing, I can't have you have that in your final exam with you. So
It's like stuff you told us to write down or something.
I haven't told you to write down anything.
I
You
have.
said to write down the non-metal.
Oh, well, yeah, non-metals, metals, and alloys, right? But besides that, nothing else. So make sure you have no writing at all in your periodic table. You can't have your exam. Make sure you have your own. You can't share with anybody.
Does this
Okay.
it's like the colored one?
Yes. Okay, so this will help you memorize the order of the orbitals. So I want you to go ahead and write down what you're seeing on here. Do you see 1s at the top? You have 1s right here, 1s right there. And then you have 2s right here. All of this. So basically go ahead, you don't have to color this, I mean, but go ahead and write in what you see as the 2p block, the 2s block.
So we can write on our.
Well, you're gonna write down this, right? But this all I want you to write down is just, can you, yes, yeah. So I want you to write down each of these blocks on here, and this will help you greatly in knowing how to do the configuration. Yes, that you can. So you can, this is the only thing you write down your test. It is the 2p, 3p, 3d, etc. That you can have in your exam with you. Let me go back. I'm sorry. I'm gonna go back in a second. I just need to make sure that Zoom is still working properly. There you go. So basically write in all these blocks, you know, where the 2p block is, where the 3p block is, all, basically every, you know, 7p, 6p, with the lines through it, so you know where each block is. And while you're doing that, let me pass out your study guides for the final exam. And you'll have time in class to work on your exam review.
Is there no 7B?
No, there's not a 70. Yeah, so it stops at 60.
Something like this. 360. Oh,
I've already done
it's like shorter than my Christmas list.
this.
No, I'm just kidding.
This is shorter than yours? No,
So basically, you're gonna have 4 days of class to work on this review packet. So you should, most people get done in class or even before Friday. But you'll have time in class basically from now
We're gonna get it done.
until Friday to get this done. And then tomorrow I'll go through a few more parts to this to make sure you understand this, but then we'll stop and review for your final exam with this packet.
Why do we have to study the first chapter of every science book?
What do you mean?
They're like verbatim for each other. It's like
Oh, scientific method, theory, law,
theory,
yeah.
law.
Yeah, that's just an important part about science.
Biology is the study of mind. Chemistry is the study of movement of atoms.
Okay, so how do you use this? Let me go through how we use this. So let's say you want to know indium's configuration. You would write down the orbitals that are in indium. You just always start from the beginning, right? 1s1, 1s2, 2s2, 2p6. So do you see how that happens? You just go row by row. 3s2, 3p6, 4s2, 3d10, 4p6. You just keep on going row by row. 5s2, 4d10. Then you get to indium, which would be 5p1. So you would write down all of that to show how the electrons build to make up that element. So you have to memorize it because it's on your periodic table for you. You just go row by row and write down all the orbitals you see. You know?
So do they know if we can get a bigger atom than
They don't know for
that
sure.
last
Yeah, they're
chapter?
not, they don't know. They haven't made one yet, but we don't know if we can.
Would it have to break these laws? Because
Yeah, we're not sure. We really don't know at this point.
is this a theory or is this a law? That there's
Well,
like 7.
okay,
p-
Theories versus laws. These are different things. Theories explain why something is the way it is. Laws just say this is how it is. So this would be a bit kind of both. I mean, because a law would just say that this is the orbital shape, right? It wouldn't explain how or why it's that shape. It just said this is the orbital shape. A theory would explain why it's that shape.
And that's the answer to number 3.
Did you have a question, Lauren? Or thought you had your hand up?
Oh, on the bottom, for 57, like for lanthanum and actinium, it's not included on this one.
Oh, basically what happened, that's a good question. So do you see really fast, everybody? So LA and AC, on some periodic tables, I think yours has this, they're down here. So chemists can't agree on where to put them. So some chemists put them down here, some up here. I think yours puts them down here.
What's the point of a thingy down there?
Well, this actually, it should be right here. So these two rows right here should be in this section right here. But if they were to put them in here, it'd be really, really long. And so to basically make it more like a square, they pull them out down here. It's understood that they are right here, but it just helps to make it more of a square shape than a rectangle.
Wouldn't it also mess up with the organization?
In some ways. I mean, yeah, in the middle part it would, yeah. Does everybody have this down? No, okay.
Did you say the final is gonna be all multiple choice?
Yes, I think 70 multiple choice questions. I haven't made it up exactly yet, but it's around 70 multiple choice questions.
Wait, when?
When what?
When is it?
Well, it goes in order of your final exams, like in order of your classes. So this would be your fourth class, which would be your fourth, so it'd be your fourth test Tuesday at 10. Will be this one. Okay, so tomorrow we'll go through this in more detail. Your final exam packet, you don't have to work on this yet. You can if you want to, but you're gonna have plenty of time in class to work on this too. No homework in your book tonight. Tomorrow I will assign homework for in this section, but not tonight.
Miss Holly. Miss Holly.
Can you email me for the answers?
Yes.
Actually?